During the service process of the bridge, the main issues addressed by foundation pile inspection are bearing capacity, including deformation characteristics and integrity, uniformity. See table below. We have previously studied two commonly used detection methods for pile integrity. This lesson covers the static load test method. Content of pile foundation bearing capacity detection. First, we will study the static load test. Principles, purposes, and categories of conducting pile body bearing capacity detection. Its principle is: apply vertical pressure, vertical uplift force, or horizontal thrust, step by step, on the top of the pile. And observe the settlement, uplift displacement, or horizontal displacement of the top of the pile with time. To determine corresponding single pile, vertical compressive bearing capacity, single pile vertical uplift bearing capacity, or test methods for single pile horizontal bearing capacity. Primary detection objectives. First, provide the design basis for bearing capacity in engineering. Second, for construction quality of foundation pile engineering. Provide a basis for inspection and evaluation. Third, select optimal process parameters for pile foundation construction. Fourth, put forward the design basis of bearing capacity for the new pile type in this area. The significance of static load test of foundation piles. At present, it is the most reliable method for evaluating bearing capacity and deformation characteristics, and is also the standard for comparing other methods, such as pile high strain method, with it. Categories of static load tests for foundation piles include: first, static compression test, typically used to determine single pile bearing capacity and the load displacement relationship. Second, static pull-out test, when designed to withstand tension in individual pile foundations, used to determine the allowable uplift bearing capacity of a single pile. Third, static push test, determine the horizontal bearing capacity of the pile. Proportional coefficient of horizontal resistance coefficient of pile side foundation soil. Below, we take the static compression test as an example. Briefly introduce the relevant technical requirements. Test requirements. First, test duration. Cast in place pile, after concrete reaches required age. Precast pile. Sandy soil is greater than 10 days. Clay is greater than 15 days. Silt is greater than 25 days. Second, number of test piles. Not less than 1% of total piles and minimum 3 units. Third, scope of application. Test piles providing basis for design. Load until failure occurs. When the bearing capacity of the pile is controlled by the pile body strength. Can proceed according to the loading amount specified in the design. When conducting sampling inspection of engineering piles, the loading amount should not be less than the design requirements. 2.0 times the characteristic value of single pile bearing capacity. Load test apparatus. Static load test devices for foundation piles include: first, main beam. Secondary beam. Reaction devices such as anchor piles or counterweights. Second, jacks. Oil pumps and other loading devices. Third, pressure gauges. Load measurement devices like pressure sensors or load cells. Fourth, displacement measurement devices like dial gauges or displacement sensors. after understanding the static load test devices for foundation piles. Next, we will further study the test method of static load test of foundation piles. First, we will learn the methods of two common reaction devices. Common reaction devices 1. Anchor pile method. Composed of test pile, anchor pile, girder, secondary beam, stay, anchor cage or hanging plate, end jacks, etc. Precautions. First, the reaction force provided by anchor piles and reaction beam devices should not be less than 1.5 times the estimated maximum test load. Second, center-to-center spacing between anchor piles and test piles. When the diameter or side length of the test pile is less than or equal to 800 millimeters, maybe 5 times the diameter or side length of the test pile. When the test pile diameter exceeds 800 millimeters, the above distance must not be less than 4 meters. Common reaction device 2. Stack loading method. Composed of weights, I-beams, secondary beams, girder, end jacks, etc. Weights typically use sandbags and reinforced concrete components. A minority use water tanks, bricks and steel blocks, etc. Precautions. First, the counterweight must not be less than 1.2 times the estimated maximum test load, and the counterweight should be added in one go before the test begins, and evenly and stably placed on the platform. Second, the compressive stress exerted by the counterweight on the foundation soil should not exceed 1.5 times the characteristic value of the foundation soil bearing capacity. On-site test. Test method. Adopt slow maintained load method. If there are no special design requirements, single cycle loading test may be adopted. Loading method. First, loading center should align with test pile axis. Loading should be performed in stages to ensure uniform load transfer. No impact. During the loading process, the load should not exceed the specified value for each stage. Second, during load grading, each loading level is 1/10 to 1/15 of the estimated maximum load. When the lower end of the pile is in coarse-grained soil, granular soil, or hard cohesive soil, first level may apply 2 times graded load. Third, estimated maximum load. For construction inspection tests, generally, it may be taken as twice the design load. Settlement observation. First, settlement has not stabilized. Proceed to the next level of loading is prohibited. Second, the observation time for each loading level is specified as measure pile top settlement at 5, 15, 30, 45, and 60 minutes after loading. Thereafter, readings are taken every 30 minutes. Third, stability criteria. Hourly pile top settlement is less than or equal to 0.1 millimeter and occurs consecutively twice, starting from the 30th minute after applying the graded load, calculated based on 3 consecutive 30-minute settlement observations over 1.5 hours. Fourth, unloading standards. Each level of load should be maintained for 1 hour, with pile top rebound measured at 15, 30, and 60 minutes before unloading the next level. After unloading to 0, the maintenance time must not be less than 3 hours. Fifth, loading termination and ultimate load determination rules. First, total displacement is greater than or equal to 40 millimeters. The settlement amount under the current load level is greater than or equal to 5 times the settlement amount of the previous load stage. Loading can be terminated. The load one level below the termination load is taken as the ultimate load. Second, the total displacement is greater than or equal to 40 millimeters. Stability is not achieved within 24 hours after applying the current load level. Loading can be terminated. The load one level below the termination load is taken as the ultimate load. Third, coarse-grained soil, dense sandy soil or hard cohesive soil. Total settlement less than 40 millimeters. But the load has already exceeded or equal to the design load multiplied by the safety factor specified in the design. Loading can be terminated. The load at this point is taken as the ultimate load. Fourth, inspection tests during construction. Generally, loading should continue until twice the design load of the pile. If total pile settlement is less than or equal to 40 millimeters, and the settlement caused by the final loading stage not exceeding 5 times the settlement caused by previous loading, the pile may then undergo inspection. First, test pile results included in the statistics. When the range does not exceed 30% of the average value, take the average value as the ultimate vertical compressive bearing capacity of the single pile. Second, when the range exceeds 30% of the average value, the cause of excessive range should be analyzed, determined comprehensively based on specific engineering conditions. The number of test piles may be increased if necessary. Third, for column caps with 3 or fewer piles, or when the number of sampled engineering piles is fewer than 3, the lower value should be taken. In this lesson, we mainly studied: first, principles, purposes, and categories of static load test detection of foundation piles. Second, static load test devices for foundation piles. Third, test method for static load test of foundation piles. A static load tests on foundation piles are directly related to engineering safety. In engineering inspection, all cases involving load tests are all critical quality indicators. Requires our inspectors to be meticulous craftsman spirit, to ensure the test is completed successfully, provide reliable assurance for safe engineering construction. Okay, this concludes today's lesson. Goodbye. After class, please consider the following questions. First, the most reliable method to determine the bearing capacity of foundation piles is. Second, what is the stability standard for pile foundation bearing capacity detection? Under normal circumstances, how long does a static compression test for a single pile take?